Alright, so on this one you've got a man walking north at 4 feet per second, a woman walking 500 feet away at 5 feet per second, but he walks for 5 minutes first, and then 15 minutes later she's further south and he's further north. So after 20 minutes he's this far up because you've got 15 minutes plus the initial 5 minutes he was walking times 4 minutes, 4 feet per second times the number of seconds in a minute. So 20 minutes times 60 times 4 feet per second. And for her it was 15 minutes, 5 feet per second for 60 seconds in each minute. So these are the distances 48 and 4500. 500 here. So we know if this is 500, this right here is 500, and this right here is the 4800 plus the 4500. So we can use Pythagoras. We can say z squared equals 48 plus 45 squared plus 500 squared. And so you get z equals the square root of this huge number. So basically we know what x, y, and z are. We know what x prime and y prime are. So now when we take the derivative, we get 2z, z prime. We get 2x plus y, x prime plus y prime, plus 0, derivative constant 0. So now we plug in the 5 out of the 6 that we know, and we crunch everything down, and we get our answer. In this one you've got the change in the height or the altitude of the triangle is changing at 1 centimeter per minute. The area is changing at 2 centimeters per minute. So your change in h is 1, your change in a is 2. And when you when you try and figure out what b is, if you know h is 10 and a is 100, you can plug in a and h in here and figure out that b has to be 20. So now we got a, h, and b, and we got h prime and a prime. We need to find b prime. So when you take the derivative, we get a prime equals 1/2, and now you got the chain rule here. You got b times h prime plus h times b prime. And then you plug in everything you know, crunch everything down, and you get your answer. Alright, a woman drops a stone off of a cliff, and the distance it traveled is 4.9 times t to the second, t squared. So she drops one stone, and then a second later drops another, and they're asking how fast is the distance between the two stones changing. Well, the distance is 4.9 t squared. And so for the first stone, you can say x is your distance here. It's 4.9 times the amount of time after the second stone is dropped, plus the 1 second that it had been falling before the second stone dropped. And the second stone is just t squared times 4.9. Now the derivatives of those is 9.8 times each one, 9.8 times each one. So when we take z equals the difference in x and y, and we take the derivative, we get z prime equals 9.8 t plus 1, 9.8 t. And when you subtract, your t's go completely away and your answer is just 9.8. On this one you've got a cone that is changing in volume by 30, and you want to figure out the change in the height. Now we know the base and the height are equal, so halfway across, if the base is your diameter, and that equals h, then the radius is half that, which is h over 2. So if you know r is h over 2, you plug that in for r, simplify it, and now you got v in terms of h. Now when you take derivative, you get v prime, you get h prime, you get 3h squared, and it cancels partially with the pi over 12. And so here you've got your numbers, and you plug in everything you know, and you solve for it, and you get 0.38 feet per minute. This one's particularly tricky. You've got several Pythagorean triangles in here. Okay, so they say a drone is flying directly over a car, and the drone is flying east at 6, so it's going east this way at 6. The car is driving north at 20. Okay, and there's an elevation of 25 miles. All right. So how fast is the distance between the drone and the car changing? So they're asking for z prime. Well, after 5 seconds, we know that x is going to equal 20 times 5 or 100, and y is going to be 6 times 5 or 30. So you know W has to be, by Pythagoras, square root of 10,900. Now if you know W, and you know this leg as well is 25, you can figure out what Z is. So we figured out what Z is. And so if W equals this, W squared equals that, and Z squared equals that. So now we know that W squared equals X squared plus Y squared by this Pythagorean triangle there. But we also know Z squared equals 25 plus W squared. But we know what W squared is. It's X squared plus Y squared. So Z squared actually equals these two terms. Now when we take the derivative, we get 2Z, Z prime. We get 0. We get 2X, X prime, but 2Y, Y prime. And we got 5 out of the 6, and we plug in everything we know, and we get our answer of 20.3. Now this one is talking about the rate of change of the ladder. And they talk about the ladder being in example 2. In example 2, they say x prime is 4. And they also say x is 6 and y is 8, so now we know z is 10. So sine of theta is 8 over 10. And when we take cosine, which is x over 10, we take the derivative, we get negative sine theta prime equals 1 over 10 x prime. And we plug in everything that we know, and we can solve it, and we finally see that we get negative 1/2 radians per second. Boyle's law says that the formula P times V equals some constant. So when you take the derivative here, you're using the product rule. So P times the derivative of V plus V times the derivative of P equals, since it's a constant, derivative is 0. And so you get this guy here, and you can solve it for V prime. Now we know that V is 600, and we know P is 150, and we know dP P prime is 20. So when you plug in everything that you know, you get an answer of negative 80 centimeters cubed per minute. Now this one's kind of a nightmare here. You've got resistors R1 and R2. The formula for the total resistance R is 1 over R equals 1 over R1 plus 1 over R2. Okay, so at one point they give you R1 is 80, R2 is 100, so you can calculate that R is 400 over 9. If you do the math, trust me, if you plug in 80 here, 100 here, you'll get 400 over 9 for R. We know that R1 prime is 0.3, R2 prime is 0.2. And so now the only question is, what's the derivative? Well, you can write these with a negative 1 exponent. When you take the derivative, you get this with all the different primes. And you can simplify it a little bit, and plug in all the values you know, and solve for the one you don't, and you finally get your answer. It's very complicated, but that is the right answer.